All right. I would share the screen if I could figure out how. There it is. All right. And mute the people so they don't annoy each other. And let me put the schedule up here. It is November 8th. Come on. Okay. All right. Project 15 and 16 here today. And 11:15, project 17 and 18. Okay. And I got a couple of guest speakers coming. Yeah, Tuesday, November 14th, and Thursday, November 16th. Uh, 6 p.m., 1:38. All right. I've been told this guy's great.
That project 18 came to April done.
Good.
That was going through a couple hours of work, but I figured it out.
Good, good. Well, Kate Enable is very powerful. And Italian hackers are good and scary. And that's a wonderful tool. And they really seem to like writing Windows hacking tools. Not too many people do that.
Let's see, on the P3, it'll figure out, P5 will figure out 5 characters. But
yes,
5 characters is going to take a while.
Right. It's a brute force attack. So each additional character makes it like 80 times slower. Yeah. So let's see.
Now, if you did it long enough with a 6-character line, would it take years or months?
Yes. Yep. So that's why I think I gave you like 3 and 4 character passwords.
Yeah, you gave us 3 and 5.
Yeah. If you can do 5, you can do 6 and 80 times as long, and 7 and 80 times as long. So as adding a few more characters gets you out into years and centuries. That's why brute force attacks are only practical for really small things.
Well, I'm watching Mr. Robot, and he's got an Android. He's like the hacker's best device on the earth, and like he can just like put it into a machine and take over the machine.
Well, actually,
is that viable, really?
Well, there's some attacks that work like that. Sometimes it's that easy. Usually, it's not that easy. It's that easy against really old operating systems. Just from Metasploit, you got a root shell, and ones that make a terrible mistake. So every now and then, something comes out that's easy, like the Eternal Romance from the NSA. You just take over Windows machines, you totally have them. So here's.
Puts the phone on top of the other and gets all the information.
Oh well, that I don't know about. That's some kind of wireless attack. That sounds like nonsense. There are occasionally Bluetooth flaws, but usually not that simple.
Yeah. I've watched it 3 times now. I'm getting into the parts where it's like, no, this.
Well, you'd have to. There might be certain circumstances under which that was true, but not very often.
Yeah.
Anyway, so this is kind of cute. These guys have an IoT attack script you could download, and you put it on one of the common black hat portals, and it has a secret backdoor on it, so that when you download this thing, you can start taking over devices, but you also give the attacker complete control of your computer. So that kind of tends to happen. A lot of the hacking tools you download are poisoned. It's the same thing true of BitTorrent, movies you download and such. So this is a self-driving car in Las Vegas. You hailed it and people could take a ride in it. And the very first day they used it, it crashed. This truck pulled right in front of it and it stopped and the truck kept going and hit it. So it was the human fault, not the robot's fault. But still, that's kind of an amusing start. I'm going to write projects for cryptography class using Hyperledger. I think this is IBM's IBM's blockchain technology, and they're pushing it pretty hard. When I was in Rochester at the pen testing contest, IBM was there talking about their stuff, and Hyperledger looks like one of the things worth checking out. So I'll probably add that to the class, and we'll see how it goes. It's their blockchain technology.
Oh, so blockchain for Bitcoin.
Well, not for Bitcoin, but imitating Bitcoin for banks. And supposedly, it only runs in a closed network and it doesn't have to waste so much computer time. And I got to play with it and see. But they were actually pushing it that people should use it for legitimate business purposes.
Like banking, Wells Fargo.
Right. Yeah. Every bank is doing it, and a lot of them are basing it on IBM's Hyperledger. So I should learn how to do it. There are like 3 or 4 versions of blockchains coming out for use. So this is pretty good. This Chrome fix today included what they call a persistent code execution, where they had a whole series of vulnerabilities, and they could take over the machine, and they paid $100,000 for that. So that's a pretty good bug bounty. Google is one of the better ones. On the other hand, this is not easy to do. This is not amateur work. That's pretty serious. But you can make a serious amount of money with bug bounties if you really are the best. I've seen many articles about this, and it is impossible for me to believe that even Facebook would be this stupid. I mean, Facebook has an unending series of disasters about privacy. So now they want to do something about revenge porn. So what they want you to do is take your nude pictures when you break up with your boyfriend and send them up to Facebook so they can watch if someone else posts those pictures and block them. And they said they're just going to hash them and compare the hash. So why don't you just hash it locally and send the hashes up? Why? If I was Facebook, I would not want to handle the personal pictures that you don't want published. That's just asking for it. And Virus Total has this. You do not need to send a virus up to analyze. You can just send a hash up. And it'll tell you if they've seen that file before. Because in a lot of cases, you don't want to just be sending files up to the server because you don't know what they are. Anyway, this is apparently really happening in both the US and the UK. And I don't know what their intellectual malfunction is, that they don't just do the hash locally and send the hash up so your picture never goes up there.
So you don't get the goodies.
Yeah. Anyway, so here's the currency market capitalizations right now. Bitcoin is now at $123 billion, and Ethereum at $30 billion, and Bitcoin Cash at $10 billion. But the reason why this is entertaining is because the latest Ethereum smart contract, after the previous one, which was the DAO, which led to a disaster, led to an even bigger disaster. The DAO was a $30 million hack within hours of it being launched. And now there's something called parity that lets multiple people get into a wallet with multiple keys. And this guy was just a newbie playing with the code. And it turns out that if you add another address to a wallet and then delete it, it makes all the contents of the wallet inaccessible to anyone. So he destroyed $300 million in cryptocurrency by accident of other people's money, because the code left a thing called kill that anybody could issue that would destroy the wallet, which is kind of amazing. And they're trying to pressure Ethereum into forking again to try to have a do-over and undo this. And Ethereum developers are, like they did before, trying to say it's not their problem and they don't want to fork Ethereum just because one of the applications on Ethereum was written poorly and let somebody steal all the money. But Ethereum, unlike Bitcoin, gives you a computing platform and you can write a program that runs on it. And Ethereum keeps saying, if you write a program and you get hacked, that's not our problem. The only thing that's our problem is keeping the underlying currency stable. But when the disaster is big enough, they have forked in the past. So on it goes. It's amazing. And that is 1% of all the Ethereum in the world that just got destroyed. Of course, and from my count, I think 7% of all the Bitcoins in the world have been stolen by banks, by exchanges. So, cryptocurrency, sort of the first thing any average person says when you tell about cryptocurrency is, gee, some hacker could just steal it. And that is what happens over and over and over and over. So, if you do invest in cryptocurrency, you've got to store it offline on your own devices. Don't trust any of these exchanges to hold your money.
Yeah, I always use my iPhone account, I just have my blockchain account.
Well, it might be all right, but what's usually best is put it on like USB stick, something that's not connected to the internet.
Oh, really?
That's even safer. But putting it on your own device is a good move. Anyway, this is a pretty good idea. I think this might be a winner. See, a lot of people are. Let me get back to this. Okay, a lot of people are man-in-the-middling SSL. They get a root certificate, they man-in-the-middle it, and on they go. And there's a whole lot of people arguing about that. So what these guys are going to do is move SSL up the chain to layer 7, where you connect to the server over HTTP, and then over HTTP, you send a request, get a certificate, turn on encryption, encrypt everything up there, and that way nobody can man-in-the-middle it.
On the application?
Yeah. That way, all the existing man-in-the-middle attacks will not work because it's not encrypted at that level. So it will just flow through. They will feel like they're snooping on it, but then you encrypt it at a higher level where they can't intercept the handshake. Now, it seems to me like you could certainly block it with a layer 7 firewall, and that we just start another arms race. But anyway, for a while, this will enable you to bypass filters and not be intercepted. So anyway, it's an interesting idea, though, to move the cryptography just higher up the OSI model. It'll be interesting to see what comes of it all. I know the HTTPS protocol is constantly under attack. Anyway, there are a lot of variations. And all right, so let me get down to today's chapter, which is 10, and let's talk about web hacking because there's a lot of fun stuff to do here. So this is chapter 10. Okay. And here we are. All right. So we're going to talk about what a web application is and how it works, and then talk about the most common attacks and tools. So here's what's going on the internet. You have a phone or a laptop or something down here, and you're running a browser like Chrome or Firefox, and you're sending requests up to a web server with either HTTP or HTTPS, and it's then replying. And the web server is running software at the other end, which is typically IIS or Apache or maybe Nginx, all of which take requests, HTTP requests we've talked about before, like GET and POST, and they return pages back. And if you're using HTTPS, it has that complicated 7 or 9-way handshake where you get a certificate and everything's encrypted. If you use HTTP, it's not encrypted, but the result of it all is about the same. Here's the popularity of web servers as of today. For a long time, people said Apache, which is the blue line, was the most popular web server in the world. But in the last few years, Apache has declined, and Microsoft's web server has become more popular. Now, this, I think, is a reflection of Microsoft's increased quality of their product. Since 2002, Microsoft has been improving their security greatly and improving their performance greatly, making their product much more stable and much more trustworthy. And I think it eventually meant that people no longer, before Heartbleed, which came out around 2014, people would say Linux is more secure than Windows. And after Heartbleed, everybody just shut up about that. And then there was Struts vulnerability. There was a series of disasters of Linux security, and Microsoft did not have corresponding disasters, so the tide turned. Anyway, as you can see now, my IIS is more than 50% of the websites, around 50%. Here's Apache, and this green line is Nginx, which is almost beating Apache. Nginx was written by Russians to control botnets. And what it was, Apache is named that way because it's just a bunch of things patched together. It's not really named after the Indian tribe. It's one of the jokes of the Unix community. It's patchy. And it has a ton of features and a ton of components all sort of thrown together and patched together. And Nginx, the problem is you can't control a large botnet with Apache. You have more than a few thousand or there's some limit how many people can connect. And so the botnet people in Russia, the criminals that were running botnets, needed a faster web server, so they took Apache and threw away like 90% of it to keep just the bare essentials, and that's Nginx. And it was considered far more efficient. It can handle many more connections at the same time on the same hardware, but for a long time, there was no documentation except in Russian. But a few years ago, some foundations sort of brought it out in the open, made it open source, wrote some English documentation, encouraged legal people to start using it. And as you can see, starting around 2009, 2010, it started rising, and now it's gotten pretty popular because the general feeling is that you will get a lot more value out of your hardware running Nginx than you will running Apache. Anyway, those are the web servers. They're serving things up. So web applications are programs that run on the server that take data from the user and do some kind of calculation and then give you some kind of response, like login pages and online banking and email and such. And of course, if your web application has a bug, everybody on the internet can exploit that bug. So the mistake is got large consequences. So typically you have a form of some sort using HTML and form tags that collects data and sends it up to a server. And then on the server, you have a server-side script, which could be in any of a lot of languages like ASP or PHP or Cold Fusion. And so the form is on the web page here. So I had a forum years ago. I used to have a feedback form on my page before they had the Great My Professor site, which does it now outside the class. But I had a place where people could say what class they're taking and put up a comment, and then to stop spam, they had to type in the word horse because I had bots filling this thing with ads for Italian Viagra stuff. So anyway, this is what a form looks like in HTML. You put in some stuff and you press submit. This is like a Gmail login or any e-shopping site. And you do this with form tags. So you have a thing called form. The action here specifies the script. In my case, it's a Perl script, feedback5.pl. And then you have just these things. There's an option value where you can select a class. Then there's a thing here where a text area where you can type in some data. And there's another field where you can type in a horse. And then there's a submit button where you can click submit, and that will send it up to the server. So all this does is serialize the data. It puts it all in one line and then sends it up to the server. So that's what's going on here. You have forms running down here and JavaScript running in the user's browser, typically put in little program things. Like a lot of people do is when you click submit, first it checks the syntax in your browser. Like the phone number has to have the right number of digits. The password has to only be a certain length or something. It checks these things before sending it up just to save time on the server. They'll check to make sure you didn't make a mistake before even talking to the server, so they can turn the field red and say, you forgot to fill this in, you forgot to fill that in. And they don't bother their server with anything other than complete form fill out. And that's what's done here in client-side JavaScript. Then it goes up to the server, which processes it. And this, by the way, is the source of a large category of web vulnerabilities. A lot of developers don't understand that you can't trust anything done on the client. They put JavaScript in the form that will say something like only 6 digits in the, only 5 digits in the zip code field, and they don't understand that the client can just turn off JavaScript or use a proxy and put 1,000 digits in that field. So they cannot assume at the server that the constraints they enforced with client-side JavaScript have been followed, but it's a fairly common mistake. So these things are called Common Gateway Interface scripts. These are the scripts that take data from HTML forms and then process them on the server. So you use a lot of languages. Perl is a really old-fashioned way to do it. That's what I used when I wrote this thing years ago, but you can use any language at all, really, Visual Basic, Fortran, C++. So here's the one I wrote in Perl. That's the way the form looks. Here's the Perl that processes it. So you have a couple of header lines, and then you have class equals parameter class, comment equals parameter comment, and so on. These are how the parameters come in. Those parameters are the names in the HTML form. They're sent up to the server, and the param function harvests them. So I get these class comment and animal, and now I can do things. If comments has a URL in it, or the animal is not equal to horse, then say, I reject your comments, it appears to be spam. Otherwise, it takes your results and prints it here. Now, what I did here is I made a fairly common mistake at this time. I used something called results file to determine where it was going to write the comments. And that was actually on the client. This is a fairly common mistake, especially in PHP scripts. So someone who understood this, who read the HTML, could send up a different value for results file and they could deface my server by writing to the wrong place. This tends to happen, as far as I can tell, in like 3/4 of all PHP-based web pages. There is some way to trick it into writing to the wrong place. And that's how people usually hack those servers, WordPress servers and other ones. And I had that vulnerability here in earlier versions of this thing. That's why I say students hack me now and then and get extra credit, and they hacked me several times when I had this feedback form. So Microsoft wrote their own server-side language, ASP, which is just another language to write things up. And if you use ASP, you have to run it on IIS. It writes things like this with these less than % tags. This is a sort of insane thing, but web pages are written by mixing several languages in the same file. HTML is this HTML head, title, and form, but you just put in other tags like less than %, and that is not HTML, so your browser will ignore it, but some other engine will process it and see what to put there, and this will actually be filled in by the server, who recognizes this as ASP content. So it is kind of screwy and violates a lot of good programming practices and leads to a lot of problems that you actually mix several things in the same file, but that's the way the web has always worked. So Apache used to be the most popular web server. As you see, it's not anymore. I didn't get this slide updated when I went through my slides today, but it's free and open source. And so you can write your page using a variety of scripting languages like JavaScript or VBScript or PHP. PHP is very common on Linux-based systems. It's considered a cowboy language. It's very easy to do things fast, very hard to make it really maintainable and really do professional quality work. It's something that amateurs and small companies tend to use, and then big companies move over to Java when they get serious and they want to have code that can be used for years and maintained and run on a giant cluster and all that jazz. So PHP, you start with this less than question mark PHP and end with question mark greater than. And the code inside there is, again, not HTML, it's PHP. And so here's an example. This will just echo hello world. Echo is not an HTML command, it's a PHP command. So the stuff inside those tags is a different language. And a PHP-enabled server will print hello world and send it down to the user. PHP has a lot of vulnerabilities. The language itself has the usual kind of vulnerabilities, specific, things that get CVE numbers, like mistakes that get fixed. But the way it's commonly used, it tends to be vulnerable through errors in the programmer. Typically, a PHP page will have a URL that's PHP file equals something, and you can change that file to print to a different file. Simple logic errors, not fundamental errors in the protocol, but just common logic errors in the way it's commonly used. ColdFusion is a proprietary language from Adobe, and it's expensive, but you've brought things in ColdFusion markup language, and so they start with these CF tags, then less than CF something, and greater than over here. They all have to have some way to put in things that look like HTML tags, but aren't HTML tags. So your HTML processor will ignore them. And so other processor, if you have the software installed on your machine, will go through and find those tags and execute it, which is kind of nuts, but that's the way it is. So ColdFusion, like everything else, has its series of vulnerabilities, like everything else, cross-site scripting and privilege escalation and everything else. So whatever version of the software you have to keep patching it and updating it, or you'll be falling to known attacks. VBScript was Microsoft scripting language to, again, be executed by the browser. There was their attempt to compete with JavaScript. I think it was never much of a hit, but it has these things called script type, text equals VBScript, and then you put script in there, it does things. It works in Internet Explorer and for, I suppose, Edge, but not Firefox. But I think even Microsoft is abandoning VBScript. They usually do that after a few years. They make products that compete with something where they're just going to lose. Like they have a competitor for Flash called Silverlight, and they just give up and abandon it. They had Windows Phone, they just give up and abandon it. They often attack something that is invulnerable and ram their head against it until they finally just give up. It's a common Microsoft move. So VBScript has had its vulnerabilities too. And JavaScript is a huge hit. JavaScript is getting more and more important. There's a ton of modern JavaScript-based frameworks like Node.js and React.js that is making it come back. And this is because about 5 or 6 years ago, Mozilla realized that JavaScript ran extremely slowly in Internet Explorer and for no good reason. And Mozilla and Chrome updated their JavaScript engine to make it run 100 times faster. And suddenly it became practical to do all sorts of sophisticated things in JavaScript, and people ran with that. Now JavaScript is a big, JavaScript derivatives are a big part of the web. So here's JavaScript. You just have script type equals text/JavaScript, and then you just have a function that parses up an alert box, and then script with a /script tag, and on you go. So it's you can write any kind of stuff you want in here. It's a pretty simple language. It's quite popular. It's had its vulnerabilities and patches too, of course, like everything else. And so I looked today to find the popularity of various languages. And I think, years ago we thought one language would win, and it's just so far from that. As you can see, the most popular language in the world is Java, but that's 12%. Then comes C of various kinds, then Python, JavaScript, PHP, Visual Basic. Swift has fallen way down to here. That was Apple's new language for programming iOS. They trumpeted it, but it seems to be very unpopular. And way down here is Visual Basic. But Visual Basic.net is a little higher, but you see that's like 1 or 2%. So, if you don't want to know what language to study, Java is complicated and hard to program in, and so are all versions of C. They're structured compiled languages, and they're pretty painful. You're not for beginners. That's why I say beginners, I highly recommend starting with Python. Python is much easier than Java or C, and still quite powerful and popular. So a logical thing to do if you've never programmed at all is learn Python. And then if you want to go on programming, learn something like C or JavaScript. But you don't want to start, or C or Java rather. You don't want to start with C or Java because they're sort of baffling. Python is so easy. You can do things in just a couple lines. Yeah?
Ruby and Perl so far down the list. That being newer languages.
Well, Perl has been around for a really long time, and it got voted recently as the most hated language. Perl, people hate Perl. Perl is syntax gives you a headache. It's frustrating. It's really specialized for only one job, which is processing large text files, and it's visible for anything else. Ruby was a Japanese language, very beautiful, very clean, but it never caught on too much. I don't know why. Metasploit's written in Ruby. The code is very pretty, easy to read. It looks good to me, but I don't know why it never caught on, although I don't see Ruby being compiled much. And you'd have to be a compiled language to get up with Java and C. They're complicated to write, but they're compiled so they run much faster, and they have the property that you can distribute compiled code without releasing your source code, especially with C. That's what people have been doing all along. So that makes it possible to protect your intellectual property by letting people use it without giving them the right to modify it or copy it.
Right.
And that's, yeah, they only have the compiled version, and so it's really hard for them to modify it. It's not quite impossible, but it's very, very difficult. So in practice, you can write a huge thing like Microsoft Office and give it to 1 million people, and really not too many people are going to be cloning and copying your stuff. Whereas if you were, but anyway, yeah, Ruby never quite caught on. It's been around a while. Anyway, it's useful to know, especially for you students who are going to study something, you need to have some clue what's popular. And I know here they base the CS program here, I think they push primarily Java and then C or C++. And I must say they appear to be right. Those are the real ones that people will pay you if you want to be a programmer. Those are pretty good choices of what you should know. All right, I got a few Kahoots about that stuff. Let me bring them up. All right, my Kahoots. 123, 10A, okay. And it's set to randomize things, good. Bring up the glorious Kahoot music. There we go. And I went through a ridiculous meeting today to have people lie to me, but we did get paper, so I have something to write on. If people are going to lie to me, they should at least give me some paper. All right, so I got 4 people in the room and about 10 people online, so I bet a few more are coming. 12 online. I think I count. Probably 11 of those are real. Anyway, this is CNIT 123. And it's 11, 8, 17. Okay, I'll wait another 5 seconds. All right, looks like, aha. All right. I guess we got everyone that's coming. 5 questions. What's Microsoft's web server? All right, good. That's IIS, Internet Information Services. And what's the most popular web server? Oh my goodness, it's IIS. I commented as went by. It used to be Apache, but for the last couple of years, it's been IIS. All right. Which of these is not a programming language? That's it. We went through that in a previous chapter. HTML does not have branching, looping, and testing. It's just markup. All you do is say things should be big, things should be on the left, things should be on the right. It's markup, but it's not programming. All the rest of these have variables and loops and all the good stuff you need for programming. What language uses those tags? Less than, question mark, and so on. That's PHP. All right. And what's the most popular programming language? That's Java. According to that one study, I don't know how they collect their data, so there may be some variation, but that's what they said. So Benham and Totoro, who will have to tell me who they are, and Chadbourne. I think I know who Chadbourne is. I think Chadbourne and Benham are close to their real names. Is Totoro here? You're Totoro? Yeah, so Benham's a real name, right? Yeah, and Totoro is the one that doesn't look like a real name. Yeah, perhaps this is a chat person telling me who Totoro is. Ah, okay, good. All right, I got your name. I'm glad you told me because indeed it's not very close to that name. All right, good. So these people get 3 each. All right, well, you haven't been here an hour yet, so I'm going to charge ahead. I've got some demonstrations. It'll take some time when we get to them. So the next thing you have to do is after you have a web server and a CGI script that will collect data from the user and be able to do processing on it, you usually want to put the result in some kind of database and query a database. For example, if they're trying to log in, you have to query some database that has usernames and passwords, or hopefully hashed passwords, but it has the information to tell you if they've given you valid credentials. And if they're shopping, you have to store credit card numbers and addresses and products and all that jazz. So you use HTTP or HTTPS to go from a client to the server, and then from the web server, you go to the database server with one of these technologies, ODBC, or some of the later ones that do it. And that's just a way to package data and move it across the network. And typically, you do not allow the database server to receive any traffic directly from the internet. It's too important. It's full of private information. You use access control lists in your routers to filter to do traffic controls, so the only thing allowed to talk to it is your web server, and that's why attackers have to pivot. You have to take over the web server, get root, install persistent malware, and then forward the attacks through that to scan the network again and find the things on the other side, because the database server will not be visible directly from the internet. So you can connect with a variety of technologies. One of the earliest ones was open database connectivity that can have a whole variety of databases talk to a whole variety of servers. And there are just some later versions that do this in other ways. It's just a standard way to format data and move it over a network and send some kind of query to the database, which can then reply like, I want to know the hash for this user's password. Let me see it and see if it matches, something like that. OLE, DB, and ADO are just later technologies that do the same job. All right, so if our application security is a specialty of security and a really important one, securing web applications, which is different than securing operating systems or networks and such. And so if someone can take over your web server software, they can deface your website, they can get over to the database if they can get in there to steal the data, and they might be able to gain root access on other applications depending on what vulnerability they got. So specifically to handle this, we have OWASP. The Open Web Application Security Project is a open source club that people join, and every company is in there. My students and I several years ago went to the RSA, and we were the representatives of OWASP at their booth, and they said, please get people to sign up, and everybody was already a member. Or just day long, everybody would come by and say, I'm in OWASP, I love them. Everybody loves them. There are other open source groups like ICANN that have a really bad reputation. They're always fighting among themselves, suing each other. Everybody hates them. But OWASP, everybody loves them. And they have conventions now and then. The San Francisco chapter doesn't seem to meet that often, but the Silicon Valley chapter is pretty active. Anyway, OWASP does a lot of things to help developers secure their websites, but the biggest, most famous thing they do is the top 10 list. And they have a new version every 3 years or so, and this is the Release Candidate 2 version of the 2017. Technically, it might still be revised, but it looks like they pretty much settled on this. Number 1 is injection. SQL injection and other similar code injection. This is the number 1 worst problem on the web. It is so dangerous, and it never seems to get any better. SQL injection is the most common form of it, but there are other ones injecting other things. But this is where you can take a field that's supposed to contain just data, like a password, and you can put commands in there that are executed on the server. Sounds insane, but it happens to about 11% of web applications that are vulnerable to this, and it's very easy to exploit and very devastating when it happens. And this is how all the big data was stolen. Broken authentication means that you don't have a good system to tell who the user is. So somehow it is possible for another person to gain administrator rights, for example, impersonate another person, because the token that identifies who you are can be forged or stolen, or some way you can trick the system into not knowing who you are. Sensitive data exposure is big. This keeps on happening, that you can trick a server into revealing source code or the contents of a database or other data that it shouldn't be just handing out. XE is something that came up in the mobile device class quite a bit. XML can refer to external entities. You can add external style sheets. It's built into the language. You can put in a request to add external code to the database. And that, of course, is dangerous. The external code might be malicious, and it's a common vulnerability that you're able to trick your XML-based page into adding code that came from a malicious server and causes you to get privileges you shouldn't have. A broken access control is like A2. Broken authentication means you don't correctly figure out who the user is. Broken access control means even if you do know who the user is, you don't correctly assign permissions. So even though they are not administrator, there aren't really enough permissions to stop them from doing administrative things. They're slightly different, but they amount to about the same thing, that users can do what they should not be able to do, given who they are. Security misconfiguration is the most common issue, which is a whole lot of things like open S3 buckets on Amazon. That's a big one. There's a guy at Malwarebytes, Chris Vickery, I think, keeps finding enormous amounts of data stuck on Amazon insecurely, where he keeps finding all these private information, misconfigured headers, error messages containing sensitive information, not patching, just a variety of poor security practices that get you hacked. Cross-site scripting, we're going to go through. This is where you get to put script code in one context that is run in another inappropriate context. The most common version is where you let users put content on a page like a Facebook wall, and other users can see that content, but you let them put script tags up. So they make scripts that run on other users' browsers. That's the most common type of cross-site scripting, but there are other types. And then there's deserialization, which I'll talk about before. I mentioned it a little bit earlier. Serializing is taking data that's going up to the server and just putting it in a long string. It can be a long string of text or binary. And so it's in some somewhat encoded form. It gets to the server, and then it gets decoded. And because it passed in a coded form, it's possible that an attacker can add malicious stuff to it, and you won't notice it, and you end up running code on the server. Then there's using components with known vulnerabilities. This is what happened with Heartbleed. There was a flaw in the OpenSSL library used by almost every Linux server for 2 years. Nobody noticed, so they were all using this software that was unsafe. And that keeps on happening over and over. And I'm really glad to see A10. So now I'm teaching network security monitoring. Now everyone says this is what you have to have. You have to have proper logging and monitoring of your servers. If you don't, you cannot detect attacks and respond to them. And it is new this year that this makes it to the top 10, because until recently, people thought it was okay to have logs and not look at them much. Now everybody realizes everybody has to have logs, and they have to have some kind of log monitoring tool like an SIEM system that warns you when bad things are happening. If you don't, you'll never be secure, because all your other defenses will really never keep everybody out. Somebody's going to get in. Yeah?
This is the new one. What fell off?
I forget, but I had the old one in the old slides. It's a good question. And if you go to the page, they show you exactly what they took off. Often the things they took off ended up being combined in other ones. There were 2 or 3 of them that were sort of strangely like the others. Like there was a special one for cross-site request forgery. And that one doesn't seem to be here specifically. It's probably just mixed into insecure authentication or something. Anyway, so here's, I wasn't sure what serialization was, so I went and looked. There's a lot of varieties. This is the kind I most commonly think of as serialization in Java. So if you have a Java object and you have a bunch of data, like here's customer name, business name, contract ID, and passkeys, so you have a series of data, it gets serialized by this serialization command, and that turns it into this mess. You have part of it you could read, and then weird binary stuff, and another part you could read. This blob of binary is what's actually sent up to the server. And the point is, this is not encrypted. It's not impossible to alter. And people could change it to include malicious content, which would then be deserialized on the server and have malicious consequences. And that's what they call one of the top 10 vulnerabilities. These attacks will depend on which serialization method you use, and there are many. Java has 4 different kinds of serialization, and every other language has a kind of serialization. But these are just ways that some kind of data is passing onto the server, and it's not obvious. So what it is until it gets deserialized on the server. So cross-site scripting, I mentioned before, this is a very common attack, and I got a page to show it. So if I go to that one, it's just games.samsclass.info. That should work. There. And I should have, my old vulnerable message board. That'll do. Okay. So here, you've used this in some of the projects, so I can say I'm Sam, an editor. And now I'm logged in as Sam. Now I can erase the old comments. and go back. And now here I can put hi, and you see hi. And now I can do things like this. This is the classic one you do to detect cross-site scripting. You put in alert. This is JavaScript. If you don't say what kind of script it is, the default is JavaScript. And then the alert is a simple tag that will just pop up a box containing this. Note the parentheses and the quotes. You have to get them right. And note the semicolon. And when I'm testing for things like this, I always keep it in the clipboard because I often file up the quotes or the semicolons or something and have to try various versions. But when you get it right, it will now pop up this box, XSS vulnerability. And when you have to click OK to get through, and then you'll see the messages behind it. So if you put that, now in this case, I haven't done any harm. All I've done is hack myself, cause a box to pop up in my browser. But anybody else that viewed the message board would also see that box. Now the box is harmless, except perhaps annoying, but that if I can do that, I can do anything. I can send a signal to a server. I can make a request on your behalf, which will be sent with your cookie. So if you have an Amazon tab open and I'm able to do this to Amazon, I could order a book and you would order it because you're logged into Amazon. Yeah.
So you're saying that however many people are logged on that website are going to log into there too?
Yes. This is if it's something where they can see what you did. For example, if Amazon was vulnerable. Yes. So if I could put this in like an Amazon comment, and then everybody that viewed the Amazon page for that book, the comment would now run a script and do something like buy the book. And this is the first one that really hit the news was the MySpace worm. Some guy made a MySpace cross-site scripting that would cause you to add him to your friends and then post the comment with the script in all of them. So in like 2 hours, he became like 100 million friends. He became the most friended guy in MySpace.
So
yeah. Yeah. That was Sammy that did that. Yeah, well, that's cool. But anyway, that's what you can do with this. You can do anything in their browser. It does not give you a shell on their machine, the ability to execute command lines. It just lets you do things in the browser, but a lot of bad things can happen in the browser. All right, so let me erase this one, try a couple others. This is one where you play with the document object model. So let's put that in there. So I post that comment, and now I end up at a different website. See, what this is doing is, this is inside JavaScript. You can refer to any part of the page, and there's an object model. You go to document, there's a document location. Every field on the page, every object on the page can be referred to, and the location refers to this bar up here, the location bar. So I can change that location bar to point to a different website. So now anybody that views this comment, their browser will move to that other website. This is what happened to Obama. Hillary Clinton and Obama in 2008, I think, when they were running, 2008, they were running in the primaries against each other, Democratic primaries. They both put up PHP-BB-based boards for their supporters to post comments and talk about rallies and stuff. And they were both vulnerable to cross-site scripting. But some Hillary supporter noticed it before the Obama supporters did, and they put a comment on Obama's website. So you'd load his website, it would say, vote for Obama, Obama's platform and this, pictures of Obama, then comments would come in, go halfway down the comments, and blam, you're over to Hillary. Because they put one of these on his page that redirected to Hillary. And so you could have done it the other way, but it happened to happen to Obama. This is the kind of thing. So this means I could redirect you to go to a malicious website. And you can do anything that JavaScript can do, and that turns out to be quite a bit. For example, this is the one that's most common probably, is iframes. So you put in an iframe source, and now you have the website with the comments, and you have extra content from another website here. And what you usually do is shrink the size of it to 0, so it's not visible. And now you'll see the website, like might be Amazon, and there's extra content coming from a malicious server, adding like malware to the site. So now you'll get infected, I'm taking over your machine, I'm stealing your money, and Amazon is getting blamed for it because the URL up here says Amazon. And so what happens is your antivirus will report you got a virus from the Amazon website. It'll then report back to your McAfee and Norton, and that will eventually find its way back to Google. So your site will start getting flagged, antivirus will start blocking your site, and Google will start blocking searches to your site, even when there is no malware on your server. Because users whose browser thinks they're at your site are in fact getting infected, and you'll get blamed for it. So it does reputation damage to the server and, of course, hurts the customers. And this is the one that you can use to steal Cookies. So this shows you cookies. I don't have much of a cookie here. I don't know why. But anyway, you could steal the content of a cookie. And a cookie usually is all it takes to authenticate you. So if you were logged into Amazon and Amazon had a cross-site scripting vulnerability, I could take your cookie and put it in an alert, which is not going to hurt you, but I could just as well send it to a server, which would harvest it. And now I can use that cookie to imitate you. And that's cross-site request forgery is what they call it. I steal the cookie, I reuse the cookie, I get in your account, and almost all the web is vulnerable to this. Yeah.
So you could order something on that person's account?
Yeah, I could log in as you from somewhere else. Now, there are ways to prevent it. There's quite a few. One of the simplest ways, well, there's a thing called an anti-CSRF token. It could tie it to your machine somehow, like your IP address or something. So that if I try to send it from another machine, it won't take it. But most people, very few developers think of that. And so cookies can be reused. And I did a talk at DEF CON about this a while ago and stuff. In fact, most websites, I can even save the cookie and reuse it later, like a year later, and it'll still let you in. Even after you changed your password, the old cookie will still work. About half the sites are vulnerable like that. It's pretty amazing. A cookie is actually more dangerous than stealing your password in many cases. It shouldn't be, but it is. People are just sloppy about how they handle and generate cookies.
Does the cookies just stay the same when you change the password?
No, it makes a new cookie every time, but somehow a large variety of web servers, the old cookies never stop working. All the logout button does is delete the cookie from your browser. But if I save the cookie first, I can keep using it forever. That's true about half the websites I tested. Anyway, so that's the game. You can hijack someone else's session. You can perhaps steal passwords stored in the browser, redirect the web page. And if there's another vulnerability in the browser, you can take over their machine. You know, the sky's the limit. And you may notice that $100,000 exploit was like 5 exploits chained together. And that's typically what you have to do. One exploit alone doesn't really get you everything. You usually have to have a series of vulnerabilities that you chain together to get something really big done. So if you want to find these vulnerabilities in a website, you want to consider if there are dynamic web pages that process something at the other end. If it's connecting to a database, you want to consider how it connects to that database. How's the data moved? Look at how users are authenticated. That's often a weak spot. What do they pass up to the server? What comes back? If there's a cookie, does it have a random number? Is that number really random? People keep making mistakes, like just using simple counting up numbers for the supposedly random numbers so you can guess what somebody else's cookie is and things like that. So even if your web page is completely static and doesn't have any data coming up with form tags and doesn't have any processing, it can still be vulnerable to certain attacks like directory traversal. You used to be able to just go up to the URL and put in .. and browse through the file system to find executable code and execute it. And that still happens on occasion, although it's much less common than it used to be. And then there's SQL injection. SQL injection abuses servers that process data. So if you have someone who is trying to log in, there'll be a SQL command like this on the server. Where you select information from the customer table where username equals name and password equals PW, and name and PW are values that came in from the user in a form. And then if there's a valid name and password there, then this condition will be true, and you'll proceed to something that lets them see an authenticated page and buy a product or make a post or something. Otherwise, you'll reject them and say they haven't logged in correctly. But if you allow them to put in an apostrophe, and an apostrophe is also the delimiter around the name, then you can break the syntax. So if you put in this for your name and password, apostrophe or 1 = 1 .. then the username turns into this, apostrophe or 1 = 1. So the username equals nothing or 1 = 1, and this starts a comment tag, so the rest of the line is ignored. So this condition, which the developer intended to say, if the username is in the database and the password is correct, now says if the username is empty or 1 = 1. And this is one condition that's probably not true, but this is always true. So the net thing is always true, so it will pass this test as if it were true. So on a SQL injection vulnerable website, this or some variation of it, that injection with an apostrophe will often let you log in as the first user in a database, which is typically the root. So you don't need a valid name and password. That you can put in something that will confuse the code so it thinks you've logged in when you haven't. Yeah.
Using this, you can use this for, say, any username or password, like City College. If I was to put in that.
Yes.
or equals 1
with the apostrophe. If it was vulnerable, you'd get in. Although they use sometimes double quotes, sometimes backtick, sometimes use a different thing for the comment. So there are various versions of it. But yeah, there's a list of like the top 10 or 20 of these. And if you try them all on a vulnerable server, you get in. And the number of vulnerable servers is 11% of the web. And that has not changed since Rainforest Puppy developed this attack almost 15 years ago. So that's why I wanted to work through this project, because this is what you'll have to do. And this, I think, is the best way to learn this, is to go through a few steps with it. So this is your homework due in a couple weeks. And I just want to show you how it looks. And I've recorded a video for part of it here, because in the past I've had students want to review it. So here, this is an SQLOL database. It's a deliberately vulnerable test database. I recommend resetting it because students can hack into it and they often do crazy things. So if you haven't used databases, this is how databases are. One thing, I used to be a database administrator. Most companies start with Excel. Almost everybody in business knows how to use Excel to make a spreadsheet or something, and they start running companies with Excel, but Excel is not good enough to run a company. If you have one list of data, like you have one customer buying something, you have product amount, and then total, that's what Excel is for. But if you have a company, you have employees, you have customers, you have products in the warehouse, you have money coming in, you have various things that are not really connected to each other that you have to keep track of. And so you put it in a database. So here's a very simple database. I got username and ISBN in one table, and I got username, name, and SSN in another table. Now these could all be in one table for this simple case, but this is a very simple example of a database. So you have two tables, and each one of these rows is called a record. And the way you use a database is with select queries. So you notice there's this thing called users and this thing called SSN. So if I select star from SQLOL users, I get all the information in the users table. Now if I select star from SQLOL SSN, I get everything in the SSN database. So that's how SQL is intended to be used. Now, you do not normally allow the end user to type into a field that just does select queries, because obviously they could steal all the data. What they get to do is put in something more limited, but this is the actual query that runs on the server to get the data. So here's things to try. I can select just the name from that field. Instead of star, I can select name. Then I will get the names, but not the SSNs. This is how SQL looks. It's a pretty simple language. I can select something and I can change its name. So if I wanted to select SSN and have it interpreted as name, that is valid. I can select SSN, but then call the field name. And now I get SSNs, and it's not showing the title, but the actual name of this column is now called name. And that's important, because if I had a field that was only going to show the names, and I wanted to steal the social security numbers, I'd have to somehow trick it into thinking they were names to put them in, and that's a way to do it. So now I can, you can limit the queries, and this is usually what you have. I want to get everything where name is Herc Derper. This is what might happen if you log into something like Facebook, and then you want to see your profile. I want all the information about me. I'm not entitled to have information about other people, but I am allowed to have information about me, so it will have this clause where name equals your name. So if that's true, I get all the information about that one person. This is normally all you want to let users do. So now, if I try to select for a name that is not in the database, there is no person named Fred in there, then it's going to give me, it's going to run without an error, but there are 0 results. So I get no results down here. That's what you expect. That's what happens. Now, if I, well, we'll go on. Now, I could also try to find who is not an administrator. You do not have to have names. You can also specify ISAdmin. Remember, users has this numerical field called ISAdmin. So I can ask which people are not administrators. And this is how you do that. Give me everything about the users where ISAdmin equals 0. And now I get the 3 users that are not administrators. All right. Now I can do this one. And now we're starting to get closer to injection here. Let's take a look at how this one works. This is going to give me everything from the Social Security table where the name equals Fred, and you know there are none of them with the name of Fred, or A equals A. This is always true, A equals A. So the condition is always true. So even though I don't even know one valid username, I can get all the data. This is how SQL injection works. Because there are two ways to read this. One way is what I just said, name equals Fred or A equals A. Another way to interpret this is that is all the name. If I put in a name that includes all that, then it will be, I don't know how to make it stay highlighted there. Then it will be interpreted as one name. If I'm allowed to put in apostrophes in the name, and the apostrophes are also the delimiters, then I have SQL injection. I'm able to confuse the server, and it takes this stuff in the middle, like or, which is a command, and it lets me put a command inside a name, which is run on the server as a command. This is command injection, the #1 biggest web vulnerability. I'm able to confuse the server into misinterpreting my data as a command and running it. And it is very common and very devastating. As you just saw, it gives me all the data in the database. So you can even combine data from two tables. I can do a union command to add two things together. So if I do this one, what this does is it selects username from users, union, select SSN as username from the other table. You can combine the results from two tables together, and I can take this SSN and change it to username, so it'll just add to it. So now I get 10 records. I get the usernames, and then I get the SSNs and treat it as names, drawn from two different tables. But in order to do this, I have to know the names of the tables and the names of the fields. So that's how select queries work. You can also, by the way, write into a file. You can select literal text into a file, so you can deface my server. And you have to do this later for the points. So right here, you can see this is SQLOL raw 123 project 19. I should be able to deface my server. Now I have to change the name, so I'm going to make this 11.8. That's probably not used. So I'm going to put literal text. Let's put hello from 123. Okay, into that file. I can write into a file. And temp test118.htm. Now, I did not get any results, but I didn't get an error message. That means it worked. Temp test118.htm. I should be able to put that up here. So now I have to build the URL. It'll be easiest to do it in a text editor here. So I'm going to end up there, and the start of it is going to be this stuff. Probably just this, I think. I might have to play with a couple versions of it to find it. I think that's the file I just created right there. Let's see if that works. Yeah, but that's okay. 2 slices is harmless. Oh, yeah. And there it is. So I just defaced my web server by adding an extra file. And that's this. So SQL injection can be used to write to a file. You cannot erase a file, and you cannot add to an existing file. You can only create a new file. But I'm able to tag the server with a name with this command. All right, and now I can read from a file. So if I want to read from a local file, I can do that with this command. And test118 is my name. So, oops, got to copy it again. I lost it. Wait, reading from a file is this one. Okay, load file. Okay. Now I know I have a file named test118. So I'm going to take that here. Okay. There. So if I select that, it's going to give me the contents of that file here over and over again. But I can read a file and see it on the server. So I can now read files and I can write to files from what was supposed to be just like a page where you're searching for someone. All right. And so normally, like I say, nobody would let you type in a select query. This is crazy. That's far too dangerous. What they do is they have something like a search page, like Twitter has one. You can search for a user, put in the name and see if you can find this person. So I can search for somebody like Herp Derper. I'm searching for them and it finds Herp Derper. There is a Herp Derper in the database. I can search some other usernames. If I want to find the vulnerability, I can use a name with an apostrophe in it. Now, there are people with apostrophes in their names, like Mike O'Neill. And when I search for that Mike O'Neill, I get this error. This error means that I have got a SQL injection vulnerability, and that means I'm in deep, deep trouble. Because, see, now I could get an error that says I didn't find that person. I could even get an error that says something like I got a letter where I expected a number, and that would be okay. But if I get a syntax error, that means the server is confused about what part of this is a command and what part of this is fixed data. And you can see why. Here's the command: select username from users where username like Mike O, and then it hits Neil, which is supposed to be a command like or and Neil is not a valid SQL command. That's why it crashed. And that means some part of what I put in was interpreted as a command on the server. And that's why it complains about syntax. If I can break the syntax, I can take over the box. You should never see the syntax error. Now, a lot of people turn off error messages, so it doesn't report this error, but it's still having the error on the server, and you can still take over the server. But in this case, I've let the error messages show so you can see them. So here's the process of SQL injection from zero. Remember, to have fun, I need to have the names of the databases, the names of the tables, and the names of the fields. So I have to find those. And the way you do it is there are some automatically generated tables in the database that you can query. So here, there's the one called information schema.tables, is automatically generated by MySQL when you install it and when you use it. That's how it keeps track of what tables exist. So I put in this thing with apostrophes in it as the name. And when I submit that one, I get a list of the databases. Now, the reason it works is because I put in this mess as the username. And so I put in something with just a long username with apostrophes in it, but the server misunderstood it as username like nothing, union, another whole select table schema as username from information schemas where A equals A. So it's going to take, this condition is always true, so it's going to take all the information from the table and print it out. And it's going to call it username, so it'll appear here as a found username. And now I see the names of the database. And the one that's interesting here is SQLOL. That's the one that contains the data I need. So now I found the name of the database. So that's the first step. The second step is to find the tables. So if I go here, this one will find the tables. And again, I gave it a username of all that. And so it thinks it's just a username, but it's misunderstood as username like nothing, union, select table name as username from information schema tables. These are the names of the tables. There's a table named SSN and a table named users. So now I know the name of the database, which is SQLOL, and the name of the table I want, which is SSN. Now I need to know the names of the fields in the table, and I can just repeat the process again to get that. And that's what this one does, finds the columns, which is another word for fields. So when I run this one, I give it all that mess as the username, and it misunderstood it as username like nothing or select column name as username from the columns where the table name is SSN and the schema is SQLOL. So now I know the SSN table has two fields, one called name and one called SSN. So now I know how to refer to the data I want to steal. And that's what I do down here. This will now give me everything. And there are many ways to do it. This one, I did a concatenation of name, :SSN. So I get name, :SSN for everybody. This is how more than 95% of all the stolen data in the world has been stolen, with this single problem and this single process. Because as you can see, you don't need to be a super genius at all. You just need to put stuff in a normal web form. You don't need any special attack tool. All you need to do is have strange usernames and passwords with apostrophes in them that you feed up to the server until it just gives you all the data. And there are automate tools that run it, so you don't even need to understand what you're doing, like Haviv.
It thinks it's code.
Right. That's the problem. If you have a syntax error, then I am able to send up data which will be misinterpreted as code. So all I have to do, all Haviv does, is have a library of these attacks and just try them until they work. It's
people still use databases like this?
yes. 11% of web pages are vulnerable to this. It's the most important vulnerability in the world, by far. If you only know one thing about security, this should be it. This single problem is responsible for most of the stolen data in the world.
So why people still use it?
What's that?
Why people still use it?
That's a good, well, the reason they still use it is because there is a Psychological political problem. If you go take the database classes here, they will not teach you how to do it safely. You go to school, you get an A, they teach you how to do it, you read your textbook, you do your final exam, and when you do it on the job, you make another generation of vulnerable code. It's amazing. But they do not teach security in the developer classes. So what happens is, this is a well-known problem for 15 years. As every time we fix one, and then some new person comes out of school and they put up another bad one. It's amazing. And all security is like this. We have an engine in the education system pumping out developers who don't know anything about security, who keep making the same mistakes over and over and over. And then we have a separate engine over here pumping out security people that patch them. It's nuts. The old Soviet Union used to be like this. There was a guy that made railroad spikes, and then he had another plant to melt them down and make nails, which were then used to build buildings, because it was very inefficient, because he could win a bonus 2 ways this way. That's the current system. And people are asking why. It's kind of nuts. Now, there are some attempts to fix it with grand sweeping measures, like the latest version of PHP helps prevent this. But most people don't know how to program in the latest version of PHP, and they keep using the old version. But it's a very good question. You could ask, like, why is Trump the president? Why are so many people smoking cigarettes when they know it's bad for them? A lot of stupid things are happening for no good reason. And this is one of them.
Yeah, I actually met a guy yesterday. He was for FireEye mandate.
Yeah.
And I asked him that exact same question. I asked him, like, since he used to be a developer, and I asked him, like, since you guys know what's about vulnerabilities in software engineering, why not tell the software engineer not to make that mistake while he's making the code or whatever?
Well, the problem is software engineers are very busy doing other things, like making it fast, making it scale, getting the bugs out, and security would be another whole thing they'd have to learn, and they don't have time. So you have a separate security team, and one thing Dan Kaminsky has said often is that it's probably not sensible to expect the developers to learn security. What's better is to build a platform for them to use that has security built in. That is probably the solution. They should use some kind of environment like Visual Studio, and it should automatically put in patches. But that hasn't happened yet. So this is still going on this way. Although, like I said, the latest version of PHP 7 actually does a little bit to prevent this. So someday, it'll decline for that reason. Anyway, you've been here for more than an hour. Let's take a 10-minute break, pick up at 7:15, and I'll stop the share and start another so people get a chance to step out a minute. All right. And
Oh, see.